Today, I'm pleased to introduce today's session, RAG Evals, Statistical Analysis of Retrieval Strategies, and our guest speaker is Jason Lopatecki. Jason is co-founder and CEO of Arize AI. Jason is joined today by his colleague Sally Ann DeLucia, an ML Solutions Engineer at Arize. Welcome, Jason and Sally Ann.
Hey.
Hey, thank you so much for having us, and we'll do a quick intro. So I'm a co-founder here at Arize, technical founder, and Arize is kind of AI ML observability, and we've been, to be honest, I would say measuring the performance of ranking and retrieval systems for a number of years now, and this last year with the growth of LLM and RAG has been an area of a lot of work for us, a lot of deployments for us, and what we're sharing with you today is really, I would say, notes from the trenches, what it's like in building a lot of these systems, the metrics we've been using, and really, again, sharing with the community some things that we've learned. So great to be here, and I'll let Sally Ann introduce herself.
Yeah, awesome. So I'm Sally Ann, and I'm an ML Solutions Engineer at Arize. My background is in deep learning, so it's been really exciting the last year to really see how all of that's been applied and transformed into the world that we now know as LLM. So really excited to get into this. Jason, should we get started?
Let's do it.
All right, awesome. So we do have a really informative and exciting session for you all on benchmarking and analyzing your retrieval. This is super important because we're seeing a lot of different approaches out there for like how to retrieve your context, different chunking strategies, but what we really don't see is a lot of standards and guidelines that tell you what you should do or help you evaluate these systems that you've built. And so that's something at Arize we've been thinking a lot about, and we've, as Jason said, these are notes from the trenches, some of the learnings we've found and things we've put together. So we're going to really be sharing with you all some of our guidelines for evaluating our RAG system or your RAG systems. So I first want to introduce you all to the 5 pillars of observability. And what these 5 pillars really allow us to do is get visibility into how our LLM applications are performing, and then ultimately how to improve them. That's the goal at the end of the day, is having these super high performing, reliable models in production. And so these pillars are going to be crucial for doing just that. And for today's conversation, we're really going to be focusing on this piece of evaluation, where our goal is to evaluate the LLM's output by using a separate evaluation LLM. And so let's start off by reviewing some of our building blocks here. So before we get into the specifics of like what's an eval, how do we do evaluation, I think it's really important that we understand the building blocks that really make up a successful evaluation. So starting off with, what are evals? Well, we've built an eval library, and it allows you to generate evals for either chains or individual spans. And what we're talking about in terms of retrieval is there's 2 things we want to evaluate. So the first one here is going to be on our chain, and that's going to be our QA eval. And this is really our overall performance of our RAG system. The second piece here is going to be our retrieval. So is our retrieval actually correct? And this is super important because, RAG works on retrieving context based off of similarity metrics. We're definitely going to want to make sure that whatever we're retrieving is correct. So if you're using Milvus, this is how you would evaluate your retrieval. And we're really going to focus on discussing the building blocks for evaluating these and how you can leverage these to evaluate, your entire system.
And I would say the reason we call them building blocks is we deeply believe like NDCG, MRR, traditional retrieval metrics are really ideal for evaluating retrieval systems. But to build up to those, you need some amount of kind of labels or evaluations or something you're building those off of. So when we're talking about building blocks, these are going to be building blocks towards your traditional search and retrieval metrics, which I listen to a lot of these podcasts and don't hear people talking about. And it's like that is how you really want to look at these systems, but these are going to be like the core bricks that we use in that foundation.
Yeah, I said it's a great way to describe it. So again, kind of focusing on this retrieval section here. And there's some fundamentals that we have put together at Arize for evaluating your LLMs in production. And we've applied it to our open source library and our evals. So when you're thinking about evals, we suggest using a golden data set. In our framework, we have provided some golden sets, but we've also seen a ton of our customers just building their own data set because it's really important that you trust these. At the end of the day, you want to be able to trust the evals you're using. So building a golden data set, which is really just a really good example of your data, good queries, good retrieval, good answers. And the benefit is, again, as Jason was just mentioning, that you can use this golden data set to apply, the metrics that we're familiar with, like precision, recall, F1. And this really does allow us to understand more specifically how well our model is performing, just versus using like, an averaging of scores or something like that. The second thing, oh yeah.
Yeah, I would say my little note on this is on the left side is a lot of people, if you're kind of listening to the evals ecosystem right now, a lot of people have grabbed onto an average of a number like correctness or something like that. And those of us who've lived in the trenches realize like averaging numbers don't really tell you much. You can have really skewed data that skews your number, and you don't know if you're measuring an outcome or you're measuring the weird skews in your data. So the traditional where we've ended up is for our task-based evals, we use precision recall F1 a lot. I would say if that's one thing you take away from the building block section, use a binary decision here to say, is something relevant or not a single number. And then also really build data sets or trusted data sets so you can make sure your evals are correct or you feel good about your numbers before using them.
Yeah, exactly. And then you touched on actually the second one here, which is the task based. And I think that's also important, is taking the stand on like, binary, but also the fact that they should be task based. So there's a lot of evals out there that are model based. And this, in our approach, we're really suggesting using a template and a task to define our performance. And this is really important because at the end of the day, we're just kind of adapting these foundation models for specific tasks, and then we're putting these into production. So if we're evaluating them, we really should be task specific. And that's why, we believe that the task-based approach is the best approach.
I think I saw you do a bit of a write-up on the OpenAI eval. Like it's kind of evals is this broad word. Can you describe for a second maybe the confusion, the ecosystem between the OpenAI evals, model-based evals, and maybe how they're used for Hugging Face, leaderboards, and stuff?
Yeah, absolutely. Definitely check out the piece. It gives a much broader rundown of all the different evals. But basically, the evals that you see with OpenAI are judging the model on how well it's able to do against, a specific task-based data set. So it's giving you more of the general idea of like, how well is this LLM able to generalize? How well is this eval able to answer questions? Things like that. It's more not looking at your specific tasks that you're doing, and more just looking at the general capabilities of the model. And it's meant to be more of like a starting point for development, right? Like there's a million models out there. It's impossible to keep track when everybody comes out with a new model that's saying like, hey, we have this state-of-the-art model. And so those evals allow you to compare model to model, but it doesn't really give you true insight to when you apply this to a specific task, how else is this going to perform in production? And that's what we're proposing here.
Cool. Great.
Yeah. And then the last thing here is just you want your evals to be able to run in different environments and as fast as possible. I think this is kind of a given here. A lot of times we're experimenting with different frameworks. I have LangChain and Llama Index stated here, but we really want it to be easy to compare and make these metrics useful regardless of what framework we're working in or what environment. And so I think now that we have the fundamentals, you're probably asking like, how does this all fit into when I'm actually running something into production? Well, here's an example for you all. And we have our LLM spanner chain, and there's some eval library. We have Phoenix, which is ours in parentheses there. And what we're really doing is having the data that's flowing through your LLM also be flowing through the eval library to create an eval. And maybe here you're switching out the template that you're using or your eval or the LM that you're using to do the evaluation, but this is just like the general setup, and the end result is going to be the eval that was produced by that library. And we'll get into the different components of these libraries next, as well as what those results actually look like.
And I would add that Phoenix is open source. We're not opinionated. If you want to use your own evals or you have evals that you think are good, I think all we're trying to do is tell you a little bit from the trenches of how to use these to get some NDCG, MRR type retrieval metrics from your system.
Absolutely. I kind of see our evals as kind of laying the groundwork. It's like a summary almost of everything that we've experienced. From what we've experienced, we put it together into this package. And like you said, we encourage people to try them out, but also build your own and let us know what you find.
Cool.
Okay, cool. So how do evals work? So in this example here, we're looking to run a retrieval eval on our retrieval span. So if you remember a few slides back, we had, our overall chain, which had our QA, but then we had a retrieval chain that was going to be specific for retrieval. And this is the eval that we would use for that. So we're taking our inputs, the user query, the document, and we're running our eval library. In this case, again, we're using Phoenix to get our evals. So this template here, I think this is really important to focus on because this is what we're using to instruct the LLM that we're using to evaluate our system on like how to actually evaluate what we're doing. And so we're asking, GPT-4 or 3.5 Turbo to determine like if this chunk contains the information that is relevant to answering our question. And so we're just trying to understand if our retrieval is relevant or irrelevant. So that's where the binary label comes into play, like yes or no, is it relevant? And one of the reasons, we're doing this, as we've been talking about, is to really benchmark our system. And the output of this, as Jason alluded to, is where we can start to do some analysis on the actual quality of our retrieval. And the retrieval performance and understanding our retrieval is really important because it's really difficult to do. And so, before having some of these newer eval frameworks, it was sometimes impossible to know if your retrieval was good or not. You may be digging through your responses and looking at your retrieved context and kind of just guessing. Well, with this, you get to know with a lot more detail and certainty whether or not your retrieval is performing well.
And
Yeah.
The technical thing I would add here is like you're using embeddings to find similar documents, which is a rough, coarse search approach. It's semantic search. It's finding things that are close in that latent space, but very, very rough in terms of like it's how it grabs document. I mean, it's like all dimensions are the same, and basically it's just looking at distance. What we're doing here is a much more subtle check. You're using GPT-4 to look and see if that embedding distance thing really returns something that would answer the question. So you might be relevant. We've seen examples where there's a bunch of words, platform, Arize, like tons of words that are semantically similar to the chunk returned. But does the chunk have a chance to answer the question? Is the core thing that GPT-4 is answering?
Exactly. And I think this is kind of ties to the fact that similar is not always more relevant, and I think this gives you real insight into see like, okay, we know it was the most similar, but was it actually, relevant to us all? So I want to review this retrieval eval in just a little bit more detail, breaking it down. So we see here that we have our query, then we have some chunks that were retrieved from our vector database. So this might be Zillus or Milvus as an example. And then we also have that template that we saw on our last slide. And so what we're doing is we're applying this template to every single one of these chunks relative to that query to evaluate whether or not the chunk is relevant. And when you're in production, you might not do this for every single chunk on every single run. You might opt to do some sampling just of a percentage or something, but the goal is really to get a view into how well things are doing. Leveraging, another LLM is a really great way to automate this. And I'll touch on this later on as well, but this is not to say that this is a replacement for doing human labeling. We see the best teams out there doing a combination of both, but the idea is to try to get as much data as you can around this. So automating with an LLM really empowers you to do this efficiently.
Yeah, and Majid I asked the question, like you use an LLM, you eval, how do you account for LLM's mistakes that does the evaluation? I think it's kind of hitting your same topic that you just hit there, which is I really do see the top teams right now using a mixture of both. Like there's human labels. You have human labels that say, is this relevant or not? That can't scale, but are really something you believe. Like you feel really good about the results. LM evals scales much bigger, much broader, can be proxies for production when you can't get a labeler on it. It's actually great to get a good gut check. I mean, there's teams that are just starting, if you're a hacker and you just want to get a quick gut check of your system. These evals are actually a pretty good proxy. So we don't think they're perfect. But GPT-4, but we do have reference and test data that gives you an idea of how good they are. And then you build your own, intuitions and data sets to believe it yourself.
Yep, exactly. So like if you take away from like what an eval is, again, it's like automating proxy metrics. That's what we're really doing here. And it's definitely not, like you said, a replacement for the human labeling.
Yeah.
Cool. And then for our QA eval, so that's, the second eval that we'll do for RAG systems, we again have our querying context, but this time we're also going to include our generated response because, this is ultimately what we're going to evaluate with this eval. And so we're asking the LLM whether or not the question is answered correctly based on the retrieved context. So you can see here, again, we're able to see like, was the chunk having all of the information to create a correct response. And so these are some of the Arize LLM evals and golden data sets that are available within our framework. So again, today we're focused on the retrieval and the QA eval, but there's so many others that you can use to benchmark your various tasks. And we definitely encourage you to check them out. As Jason said, you can use them as just a guideline for creating your own. Definitely want to see the community and what we're all able to come up with. So exciting stuff. I think now we're going to get into maybe some more of the fun stuff here. Jason's going to walk you through a live example and then we'll break that down a bit more after. So Jason, you want to take it away?
Yeah, I'll share here. So, first off, there was a question from the team around performance and so for the eval metrics, we have a bunch more rolling out. What we do is we do have test data sets, which Sally Ann, like it's a whole benchmark phase where you decide whether this thing is good enough for you to use as a proxy metric for performance. Again, it doesn't replace the hand labelers who might go out and help you label in production to understand or even building. But there's some performance metrics here, precision F1 recall, for different models, model types. This one, GPT-4 and 3 Turbo don't have a big difference. For some of these others like Q&A, I see big differences. So we help gut check template plus model. Is it good enough for the task? But I encourage you to build your own confidence.
And Jason, if we could just pause right there on that table. Somebody asked about, evaluating the LLM when you're doing retrieval. This is just an example here where you can see the comparison of the different LLMs and how they're performing. So just wanted to point that out.
Yeah, and this is like a pre-production benchmark. So you kind of get a feeling for your evals, how well they're doing. You save off your own golden data sets and feel good about your templates and your models. And then it runs in production. You have some proxy performance metric, and you can also do hand labeling on top of that for keeping your gut check, keeping your gut check of your metric right. But again, this is a proxy metric that scales out more than hand labeling. As you think about it, Phoenix open source, pretty awesome solution, which we're showing you with evals. It also runs as a couple lines of code with Llama Index and LangChain. So you literally drop this thing in here for retrieval. There's a little link. You click the link and it runs local. Doesn't send your data anywhere. Completely local execution where you can see your queries and see your retrieval. So we're going to talk a bit about retrieval, but I can look at like this re-ranking, the number of LLM calls in here. I have a re-ranking output here. I can drop and see the templates that are used by Llama Index and LangChain. So there's a way in which you can collect the data, and then all this data that gets collected here. So I can easily in here compare like one retrieval approach, to maybe simpler approaches. So you can see there's probably maybe six LLM calls on this one. So or maybe the very simplest approach here where there is no re-ranking and it's just a simple retrieval. You could see the chunks retrieved, performance metrics. So it's a really good debugging tool, open source, one line of integration with Llama Index and LangChain. What's really nice about it is you can bring all this data back into a data frame. So we'll release this notebook after, but this is an example on the Arize docs where all the metrics that you see Sally Ann running with the queries and NRR and MRR and ECG and these evals, you can just run yourself and build your own confidence that this works for your system. You can also just point it at your docs. So if you have your docs and your questions, the same script will run. We'll provide it post call here.
Awesome. Share my screen again. All right. Yeah. Anything else you wanted to chat about in terms of that example?
Yeah. I mean, there's another question dropped in, and we're going to go through a little bit of this, but in your experience, what are some ways to improve retrieval if the eval results turn out not so great? Would you focus on better document processing, better similar metrics? And I think the answer is like, we've seen a lot of different failure scenarios. So I would first off say the goal of Phoenix is to actually get you to maybe examples of where those problems are. Examples of problems I've seen people with tons of duplicate chunks where all the chunks in the context window are like the same thing, because they had French and English, but they're all different web pages for different countries, but they're all English language and all the chunks were overlapping. So there's some simple things like that. You can get as complex as what Sally Ann's going to go through, which is like your K is too big. You're returning 10 and it's killing performance, and the model you're using really needs a small number of contexts. You can get examples where your chunk sizes are too small, which is another one Sally Ann will run through here. I've seen examples of just like returning garbage, like there's some just messiness in your docs, and like it's like tons of characters, and that's retrieving a chunks which you don't have English. So there's lots of things around cleanliness of data, of setting up the retrieval system with the right parameterization, which is kind of what the script helps you do. And then just giving you tools to debug, because there's a million failure modes, I think.
Yep.
Yep.
Absolutely. And I think like that question that we just got in the chat is one of the most common questions we get asked. And like, again, it's the part of the motivation behind this all is actually having information to guide that, because there are so many different pieces of that could be causing poor performance. And so as Jason mentioned, we're going to get into specifics and identifying these so that you can strategically decide what to do about this. Cool. So, now we've discussed some of those building blocks. We discussed, how we're building these evals. You've even seen, Jason go into the Phoenix tool and see it. But I think actually discussing how to benchmark these is a super important piece, because this is kind of where complexities start to come up. So returning to our retrieval eval. So we have our queries here. We have two queries, 0 and 1. And then we also have our various chunks that were returned. And so we've already discussed like going through our eval, and we're going to run on each of these chunks. But what we're really doing here is generating these labels using our eval template. So if you remember in our eval template, we were asking, is the retrieved context irrelevant or relevant? And so that's what these 0s and 1s indicate. So 1 is a relevant piece of context, 0 is an irrelevant piece of context. And so for our first query, we returned 3 relevant pieces of context, but not so good in our second query here. We only have 1 piece of relevant context. So what we can do with these labels, and this is kind of the power that Jason was talking about in the beginning, is we can start to say like, okay, well, what's my precision at 4, for example, or what's my MRR for these? And so once you have your retrieval set up and you have your queries and you're confident in your evals, now we're like really starting to apply those traditional search and retrieval metrics, which just makes it a lot easier, and it makes you more confident in what you're actually evaluating in terms of your performance. We talked about just having this average score. Well, if you have skewness in your data or anything like that, you can't really understand the overall performance. This really allows you to do that, and probably also a way that you're more comfortable with, because these methods have been around for quite a while. And we do have some really great example notebooks for this using Phoenix. And so we'll definitely be sure to share that with you, but definitely encourage you to check it out because it does make life a lot easier. In terms of our second retrieval method, or I'm sorry, eval method, our Q&A, we're going to take a look at the query, the chunk, and the answer. So this is like an additional level of analysis that should be done. So like the first part is like, was our retrieval good? But now we're trying to say like, well, was our answer correct or incorrect? And another kind of piece of this is the fact that like, did the LLM know the full answer based on the retrieved context? So sometimes maybe it has partial the answer, but the full answer is not included in the context. And this eval will also help you understand that. And there's a lot to be learned, I think, on this QA portion, because there's a lot that can affect the QA, and we don't really know exactly what defines good retrieval. So definitely expecting more to come up on this. But one thing that we are kind of certain about is that there is some kind of correlation between good retrieval and good QA results. Anything to add to this, Jason, before we move forward?
Yeah, I mean, there's a big question in the webinar chat, which kind of hits on exactly what you hit on, which is NDCG, MRR the things you should be looking at given the way an LLM works? And what we've seen, again, build your own intuition, use our scripts, you do whatever you think you should do. But we do see correlations between good retrieval results and the good Q&A evals here. So again, we're kind of overall, did you get the right question? Like those two, when you have good retrieval, you have good Q&A. I would say there's so much blocking and tackling that the NDCG and MRR is really helpful with, which is like the example I gave where I just had chunks with characters like that. The way we found it is just, MRR is kind of 0 for a bunch of these, and we're like, well, what's going on? And you can, it's good for getting your blocking and tackling, as you get to really, really clean data and maybe decent retrieval, like you're probably working on other things like overall looking at maybe these overall Q&A evals to understand if I'm doing the next set of tweaks are working. But I definitely think it's useful. I think it's very useful to help capture, your core setup problems in your retrieval system, but it's not the only thing. And I think that's the point here.
Yeah, for sure. And I think even the specific problem, the lost in the middle problem that they're discussing there, I do think the evals have power in helping identify that, because you're really able to see, which of the chunks are really providing good answers or which of them are really relevant. And if you have your relevant ones, in the middle, and then you notice with your Q&A that we're getting a bad response, that kind of tells you right there that we are experiencing that loss in the middle. So there's definitely value in the evals for that problem as well. Oh, cool. So we've been talking a lot about the evals. I kind of want to switch to a parallel kind of a way of evaluating models, and that is some scripts we have that help you sweep through retrieval setups. And I think this is super cool because, you're able to point to your docs and sweep through the different options. So, that question we got before of like, what do I do? Or what's the best setup? Or that question that we get all the time, this is really helpful for that. So you can set your different chunk sizes that you want to integrate across. You can set up different Ks, and then, you get the results. And, I've mentioned it a few times, but this really is one of the most common questions that we get, is how to really set up this retrieval, which is the best option. And so what we're really allowing teams to do is, sweep through these setups and then set up your system with some amount of rigor, because you have these results to power the decisions that you're making in terms of setup. And, this might be a little bit more relevant for development use cases, but nonetheless, I think it's super cool, and we're going to discuss some of the results in just a bit.
Yeah, and I would say we've kind of just started to release some of these scripts this week. Still early, so feedback is welcome. This version of scripts with Llama Index, we have a LangChain version coming, and yeah, I think it's been pretty helpful. The one caveat is, in general, evals are generally slow. I would say that actually the slowest thing is actually the querying and question and answer systems themselves. So running through hundreds and hundreds of questions, QA wise, to do these different things does take, this sweep here might take over 24 hours to run. It's not super expensive, I think, relatively speaking. Again, depends on your budgets. But the slowness is natural in a lot of these systems right now.
For sure. And, we are experimenting with that piece that is slow. So as we adjust, even in just the implementations, right? Like, re-rank takes much longer than like, an original implication of just, pulling in. So that all will definitely have a factor as well.
And to be honest, the thing that I found is slow right now. So our library, so the Phoenix library for evals is designed to like fill the pipe as much as possible, forks a bunch of calls to OpenAI. The LangChains and Llama indexes kind of do one after the other calls. So those tend to be like the gating calls right now. Those approaches are fairly slow. They wait for one to return before they kick off their next query, typically.
For sure. So
Or
let's
at
maybe
least they don't fill the pipes.
Yeah, not in the same way, at least.
Yep.
Awesome. So let's discuss maybe in a little more detail about, these individual, sweeps and what we're looking at here. So starting with like a chunk size sweep. So it's probably what you would imagine here. We're varying the number or the size of our chunks. So we have 500 and 1,000 token sizes here. And then we're able to, evaluate these to see, our relevance or correctness, or just really see the overall performance of using this chunk size. And you can see here, we're just using K as a standard 4. So in this example, we're not varying K, we're just varying our chunk size. For K, it's very similar, but now, just reverse. Now we're varying K, so we have 4 and 6 as our K values and comparing those. And we're keeping our chunk size at 500, so keeping that standard. And again, we can sweep through this to get overall performance by looking at the different K values. K values are like what is also called your context windows. It's the number of chunks that you're going to return. So definitely an important one. And then, we can also look at the retrieval transformation. So that's what we were talking about earlier with, original or re-rank or hide. So there's different transformations that you can try and compare to. So here we're taking a look at original and re-rank, and again, able to compare. And we can swap these out for different parameters as well. And it just actually gives you some results that we can analyze to really determine the best strategy. So this sweeping method is one of those ways to whoever asked the question about like how do we know a way to improve our retrieval? Well, this might be one of the ways in which you can do that, as well as the evals that we're talking about prior. So let's talk about those results that you actually get and what you can make of them. So this is a set of results from a chunking retrieval eval that we did for our chatbot that we built on Arize Doc. So this is a chatbot that's powered with our Arize documentation. We're testing on some questions that we usually get from our customer base. And I really just want to kind of preface all of this with saying that you might not see the same insights in your use case, right? So we're using different docs. Insights are going to vary there. So I don't want you to come away from this thinking that, well, Sally and Jason said that like, this is what exists. Well, this is just for our documentation. So definitely try it out with your own. But the idea is you are going to get insights. And so if we're looking at here, we have 4 different chunking methods, and we also are looking at 2 different methods and 3 different Ks. So there's a lot going on. We have all of the results or all the evals that we were just talking about in these results here. And if you look at all of the re-rank ones, so it's focusing on this kind of upper left-hand corner here, this is chunk size 100 with the 2 different ranking metrics. And I think retrieval methods. I think something that's worth noticing here is that we're definitely getting a bit better performance in terms of retrieval. So again, this is retrieval, not question and answering. We're seeing better performance there with the re-rank. So that is one insight we can see kind of right away. And then you can kind of see that, perhaps as, we get larger in our chunk sizes, or the more K, our performance goes down a little bit. Yeah.
And the expectation is as your K goes bigger, your retrieval performance does drop, and it doesn't quite drop as drastically as if you're at, the slope here is not as drastic as you would actually estimate if it was not working better. But
Sure.
we're keeping going on the other ones. Cool.
Yeah. Okay. So did you want to discuss these or the other? Did you mean the other?
I think
results?
maybe the next other results.
Yeah, the next slides. Yeah, so this one here, I want to point out too, the metric that we are using is precision at K, but of course we can also look at MRR. And so one thing to note about MRR is it's slightly more affected by the order of the retrieve context. So that's something definitely to keep in mind. It is a little bit relative, but just something that I think is worth noting. And we're seeing the same or similar patterns that we're seeing from our previous slide with precision at K. So you can see here again, re-ranks just slightly better. It's hard to see on these maps because they're not next to each other, but we're still seeing that. And then similarly, we're seeing maybe worse performance, maybe as we increase our K or we add larger chunk sizes to it. I do think that these are the 2 metrics that we really recommend using for this retrieval use case. We do definitely see places where we have better retrieval and then thus have better QA. But there's also one other component that we might want to consider. But before I do that, I did see, it's just the chat. I thought maybe we had some questions coming in.
Yeah, and I would say, again, some of these are really good at like MRR and clusters, which is what we kind of do in Phoenix, or MRR overall, like on an item by item basis, can be really helpful for troubleshooting individual problems. And then it's correlated to the next thing we're going to talk about, which is overall Q&A performance.
Absolutely. Yeah, this is just a small piece of what Phoenix really has to offer in terms of troubleshooting. But another component that I'm sure everyone here has probably thought of when they're building LLM systems is the latency. And so this is a really big thing to consider here because, as you're choosing a really, maybe complex approach, there are some trade-offs that you're going to expect between, your performance and, latency. So we really have this job of trying to balance these. So we mentioned that re-rank is more computationally expensive, so it's no really surprise here. It's a little bit more involved that there's higher latency involved with that. So that might be something that we need to balance, like between using re-rank to get better retrieval, but if latency is super important, we might want to opt for a different method. But yeah, Jason, did you have something to add?
Yeah, I mean, my addition here. So this is Cohere's re-rank calls within Llama Index put in here. And I think for anyone who is putting anything out that interacts with a human, you almost wouldn't be able to use the ones on the right, like the thing, the 4 or 6Ks and small chunks, maybe 500 chunk size. I mean, I would probably go with the smaller window, like you're going to see in the Q&A performance that the simple method and smaller window is probably the the stronger thing to go with. So I think it's important to not just be caught with the fancy new retrieval algorithm that people are putting out there, retrieval approach that someone's put out. Like, it's how well is it doing and how long does it add and delay?
For sure. And I think before you make that change, like you might see this really fancy new method and you might be quick to be like, let me put that in my system. But, this allows you to actually see what impact that's going to have in terms of, latency and performance to see, is it even going to help me improve my performance? So this is definitely useful for that. So up until, or these last few slides have been looking at this from a retrieval perspective, but we talked about it before, there's that second component, the Q&A performance. How well are we doing overall? And so that's what we really have summarized here for you. Now there's a lot of different visualizations here where we're looking at a lot of different components here. So we have chunk size, methods, our K values, and then we're looking at the percentage of incorrect from our QA evals. And so here, there's kind of this sweet spot in the middle around like 300 or 500. It kind of appears, you can see it here with this pretty low incorrect percentage here. And it's a little bit better than, the 100 size or the 1,000 size chunks. And something that, you're able to do here is to start asking questions when you see these results. So one question I had, when I was looking at these is I looked at this graph here where we're at chunk size 1,000, we're using our original and we have K of 10, which is a pretty big context window. And so this makes me start thinking like, I have a lot of incorrect responses here. Perhaps I'm overflowing the window. Maybe this is the lost in the middle problem where a relevant context is getting lost and forgotten by the LLM. So these results allow you to ask those questions, dig into that, and then really provide you with the information overall to balance these different components and really optimize your system.
I think one of the more interesting ones at patterns, and we're seeing if it's consistent across, like we're running this both on our docs and a bunch of customers docs, customers who are using it. And K going from 4 to 6 to 10 is pretty consistent, independent of retrieval method gets worse. So you're like, part of me wonders, I want to dig in deeper and confirm that result is real. It does seem to drive towards keeping the windows simple, keeping the retrieved documents of high quality, and that the more garbage you put into the window, the worse your results are going to be. We'll see how well this holds as we test on more docs and get more experience.
For sure. I'm sure you feel the same way, Jason, but I imagine all of this is going to change probably 10 more times in the coming months and years as this this really space continues to evolve. So it's an exciting time that we get to try out all of this and really find the best methods that work. All right, cool. So we've done a lot. We've covered a lot of information in the last little bit here. We've understood what evals are. We've gotten to the building blocks. We now know how to look at the results and what kind of results we can expect from running evals. And I think an important thing just to touch on here is the challenge really that we're seeing in production when it comes to some of these RAG systems. And so That really is the fact that a lot of our customers and a lot of applications and organizations out there have a lot of documents. And so this could yield, millions of chunks in your vector database. But then at the same time, we need to limit the number of chunks to something reasonable so that we have reasonable retrieval. And then, we also need to get the right pieces of context from our knowledge base. So it's a really interesting and complex problem that we have on our hands. And as we talk about, AI memory and using LLMs on, customer data or your own data, it's really going to be this problem that we're dealing with, and we're going to be dealing with it for a while because it's likely that this is really the future of these LLM ecosystems. And so what we're really talking about here is like, how do I manage how many chunks? How well is my retrieval actually doing with those chunks? And like, how do I really get the data in the best way possible to our prompt? And that's the problem we have at hand. Anything to add to this before we talk about where we're headed?
Yeah, I mean, my only point, and we're going to talk about like some of the things people are doing to solve this, but fundamentally, as you think about the next 5 years, like LLMs, the context window is going to get bigger, but it's not going to be infinite. And you're going to have documents, you're going to have data you want to give it. And that data is big and there's a lot of it typically. And so this problem of like how to feed the LLM good data into the context window and the right data, like I think it's bigger than just this RAG moment right now. It's how to make LLMs work with your data is a fundamental problem of the next X amount of years. And thinking about this is something we think about a lot. And one of those things that we're seeing right now, simple ways, kind of like the hammer method to help this is kind of the next thing we'll throw out.
Yep. And so what Jason's talking about here is what we're really finding is like a combination of semantic search with like structured filtered capabilities is really what we're seeing might be a potential solution to this. So the idea here is we're adding in this metadata. So here we've added these location metadata. So we have US, we have France, we might have other countries mixed in there. And so what this really allows you to do is filter for a specific set of data and then do your semantic search. If you think about any of like the traditional query methods like SQL, for example, people like that because it's really efficient at being able to filter down your data and get just the data that you need. And I think we believe that, as vector databases continue to evolve, we're going to see these filters being integrated more and more, and it might be the potential fix for how we can manage these millions and millions of chunks and make sure that we're getting the best possible pieces of context for our user query.
Yeah, I think this is the point. As long as the search method being like a distance approach, looking at embeddings in latent space, it is very coarse search, like you're essentially a distance sphere in latent space, and so that with that coarse method, the more chunks you get, the more likely you're just not going to get the right thing back. So I think as much as that search method remains simple, fast, and distance based, and it could get more complex, but right now it is what it is. The one of the nice solutions, easy, simple, everyone gets solutions, is, and it's one you probably have, is breaking up. You're not just stuffing all your data in, but breaking it up by some easy groups, by product category, by region, by something that or by e-commerce sites are doing it by like the filter someone might have as part of the search. So recommended, think through, especially as you're doing bigger systems.
For sure. And like kind of going back to that question we got early on about like, how do you improve your retrieval? This again might be another method you might try out here.
Cool.
Awesome. Well, we do have, or that is the end of our presentation. We'll do questions for now on, but these are some links for you all. You can go to some collabs as well as our GitHub for RAG. Also check out our Phoenix tool. Leave our GitHub a star if you feel inclined to do so. But yeah, what questions do you have for us?
Yeah, they a bunch during the.
First of all, thanks for this great session. What's the difference between original and re-rank?
Yeah, so original is just embed your query and get semantically similar stuff. So it's kind of like the very traditional RAG approach that most people are using. And then re-rank is using coheres re-rank to re-rank the context retrieved. And using llama index plus cohere as kind of version of re-rank.
Gotcha.
Cool.
And we have another question. In terms of the results, what would you do next?
Let's throw those back up on the.
Yeah. In terms of the result, I mean, so just walking through this one, like if I was going to choose my parameterization for my system right now, I would choose 300 or 500 in terms of chunk size, maybe even 3 in this case, and probably k equals, you know, 4 or 6. You use it on the small side. So I think what I would do is choose my parameterization. So this would help me in my original setup. I probably would use Phoenix to be able to catch the rest of my problems. So as I'm getting customers sending in more data, or I have test sets I want to run against, I'd use Phoenix to then really map out like, where is MRR failing? Okay, what's this group look like? Okay, is it garbage chunks or something? So I would use this for my original parameterization, and then I would use, you know, tried and true troubleshooting, building good test data sets, running it, using those tools to narrow down your general problems that you're going to probably hit constantly and consistently. And once you even get rid of them, you'll have more as you get to production. So that's probably what I would do. And it says, sorry, I didn't see chunk overlap. Yeah, chunk overlap, good question. Great question. So chunk overlap's another parameter. We'll be adding it to the script. It's not in the script now, but it's another common one that people use to improve performance. So trying to get some overlap in the chunks that are in there versus having them completely disparate. Good catch. It's not a parameter in the current script.
And I don't know about you guys, but definitely on the Milvis and Zill's team, we get a ton of questions about chunking strategy. You guys have a lot of experience, right? You've built this amazing tool set. Where do you feel like most people go wrong? And what do you sort of most commonly, and then how would you recommend people sort of avoid those like first mistakes?
Yeah. I think the core area of wrong is just like not having measurements and going after the new shiny cool thing. That kind of my push for everyone is put some measurements in place that help you understand if what like this strategy versus this strategy. And then the other thing that I would put into, and I think people go wrong, is like the data is kind of important. So putting together either some test questions or, you know, some test sets in the beginning, and sometimes you don't have them. You can generate. We did a session with Llama Index earlier this week where they have some great tools for generating questions from chunks, but synthetic data can help. It doesn't replace like the data that you have. You know, Jerry's note was like the test questions can be garbage if your chunks are garbage, so be wary. So I think the big one is come up with data, come up with tests. And then I think like the results seem to show that like, don't go too big on chunk size, don't go too small. You know, there's some amounts right now that are kind of nice given the context window and strengths of these models.
I also think considering what kind of queries and like what your system is supposed to be designed to do can be helpful in determining, you know, your chunk size. So just another helpful hint there.
So you mentioned that you were testing on your own product documentation. Does testing on something that you have domain expertise on help you interpret the results of these evals, like that kind of human checkpoint, or how does that factor in?
Yeah, I can give my answer and then I'll let Jason kind of elaborate on it a little bit. But I think, you know, when you're looking at your own LLM and you know what data it has and you know what the task at hand is, it does make it a little bit easier to evaluate the results that you're getting back. You know, for our documentation, for example, like we know that we don't have any pricing docs in our publicly available documentation. So we're looking at evals, and if we have a question on, you know, pricing, we can kind of know that, you know, it's not going to have the context to answer that question, right? So then maybe it's not a retrieval problem if that's what we're seeing in our evals. Maybe it's more like from our knowledge base or prompt engineering, I'm sorry, and making sure that it's not answering questions that it doesn't know. So I definitely think maybe not domain expertise, but like understanding what your knowledge base is, maybe maybe the documents that it has available to it, and what you're actually, you know, expecting this LLM to do is really helpful in evaluating these results. Jason, you have anything to add for that one?
I think it was good. I think it was a good, good capture of the question. And yeah, thanks.
We have another question in the chat. There are also RAG techniques to apply LLM in the retrieval phase. For example, we can retrieve more than enough chunks and use LLM to filter out the irrelevant ones. This way, since all chunks are made to be relevant, NDCG, DCG, MRR becomes less useful, I assume.
Yeah, so great question. So by the way, we did use like a fancier technique like hide. It's an example in here where we generate a more complex, a better centered question. But I think all those I think some are actually have a lot of promise. I think given the results here, the one we just mentioned, actually kind of getting stuff out of the window that doesn't, your context window that's not relevant prior to the generation step, I think actually has a lot of promise. Again, I come back to like, let's look at measurement, let's look at results. I would also come back to like, even with those fancier techniques, I still think there's a lot of things that could go wrong. And so I don't think all these metrics you get rid of. I think you're going to want them as ways of finding problems in your system. But I think they're good points. That was a good point.
And another question from an attendee: what are some other ways to re-rank without using Cohere or basic cross-encoder?
Yeah, I mean, without, I think you're going to do without a cross-encoder. I think it's going to be like you're probably using LLM or internal like LLM if you're on the fancier side, and then if you can do local models, there's I would say some approaches maybe to look at like Hugging Face type things. But yeah, I think the cross encoder and LLM are probably those approaches are probably going to be the more the things I see the more of. Yeah, I mean, the challenges with those that we've seen right now is just the timing it takes. So like, yeah, you're for those of you or those of us dealing with real-time systems, that is a challenge in these, like double calls back are taking a little bit of time. So I think that's the one that everyone's kind of fighting with right now, that to do the re-rank, which you probably could get value out of, or a lot of value out of, if you drop stuff out of the window. Doing it fast is you probably do need those local models in some way.
Great, thank you. I have a question just from personal curiosity. Yeah. Anything you guys want to share that people should keep an eye out for from the Arize and the Phoenix team?
I think, yeah, so I do think one of the key points with these evaluation sets and stuff is we're trying to like do more of these. We're going to add a session to the end of the evals set here on really synthetic data generation. We're feeling like that's a key part of like starting with your evals and getting some data together. It's not a replacement for your current data set. So expect another session on that. And then, yeah, and then Phoenix has a lot coming. So there's some great tools in there for visualizing your retrieval and embedding space. We're tying it a little bit better to the spans and traces stuff coming. Expect a lot. There's that team's has a lot in the works that we haven't rolled out. Cool.
I think that's it on questions for the moment. We'll give everyone just a last minute. But anything you guys, in thinking about what we've talked about today, anything last minute shares that you want to, any takeaways?
I don't know, feel free, love, join our community. We talk about this stuff all the time. Arize community is pretty large, and this is on our mind. Feel free to drop notes and follow up there too if you have any questions. We're all technical folks loving the space and trying to add measurement and data, a little bit of science to it. Cool.
Awesome. Celine, would you mind sharing the QR codes one more time? Perfect. This is your last chance to grab those codes. Make sure you connect with the Arize team, join their community. They've got a lot of really cool stuff going on. We will have the recording up probably later today for all of you who are asking. Thank you so much for joining the session, Sally and Jason. This has been really wonderful. We really appreciate you stopping by. And we look
Great.
forward to seeing everything that you guys build and create.
Thank you for having us. Appreciate
Yep,
it.
thanks
Yeah.
for having us.
Bye.
Thanks.